Hi everybody, welcome to physics teacher classes. Our topic is kinematics. So in the previous session we discussed about acceleration, retardation, right? Today we are going to learn some more topics. Yes, no. So before that, let us discuss something about uniform motion. Already we discussed this. Yes, what is meant by uniform motion? If the speed of the body is constant, then that motion we call as uniform motion. Yes or no? If the speed of the body is constant, then the motion is uniform motion, or if it covers equal distance in equal intervals of time, that is uniform motion. Right, here does the body have acceleration? Have an acceleration or not? If a body is in uniform motion, does it have any acceleration? What is your answer? Right, it may or may not. May or may not. Means under what circumstances, under what conditions the body has acceleration. Okay, under what conditions the body will not have acceleration, let us see. Right, for example, if a body moves in a straight line, okay, now the body has uniform motion in a straight line. The body has uniform motion in a straight line. Then what? Uniform motion means speed is constant. Straight line means direction of the speed is constant. Therefore, in this case, velocity is constant. Understood? Okay, so if the body performs uniform motion in a straight line, then speed and its direction constant, that is velocity constant. When the velocity constant, what about acceleration? Acceleration is 0. Why? Acceleration is nothing but what? Change in velocity. As the velocity constant, there is no change. Final velocity and initial velocity are same, so that acceleration is 0. Understood? Right. If the body is not moving in a straight line, for example, it is moving in a circle. It is moving in a circle. Okay, uniform motion in a circle. Right? This is a circle. Then what here? Here speed is constant, but direction of the speed is not constant. See, the direction is always changing. Yes or no? So here then velocity is not constant. Then therefore acceleration is not equal to 0. Understood? Here the direction of the velocity is changing, but the magnitude of velocity means speed is constant. So that velocity is not constant. There is change in the velocity, so that acceleration is not equal to 0. Understood? So if a body is in uniform motion means its acceleration may or may not be 0. See, in this case the acceleration is 0. That means if a body moves in a straight line with uniform motion, acceleration is 0. Right? No. If a body moves in a circular path with uniform motion, its acceleration is not equal to 0. Clear this? Now let us see what is meant by uniform acceleration. Uniform acceleration. Okay, uniform means already I said. What is that? Same. That means here acceleration should be constant. Right? Uniform motion means speed is constant. Uniform acceleration means acceleration is same, means acceleration should be constant. Okay, when it is possible, if the body covers or if the body travels with equal change in velocities, equal change in velocity in equal time intervals. Understood? No? Uniform acceleration means if the body have equal change in velocity in equal intervals of time, then the acceleration of the body is said to be uniform acceleration. Got my point? Very important one. Uniform acceleration is nothing but the acceleration of the body is constant throughout the journey. Okay, for example, if a body is moving with an acceleration of 2 meters per second square, Okay, at any point its acceleration is 2 meter per second square, then it is called uniform acceleration. Clear, sir? So that means its change in velocity is equal in equal intervals of time. This kind of motion we call as uniform accelerated motion. Right, now let us see. Acceleration is constant means it is constant in magnitude and direction both. It is constant in magnitude, and because acceleration is a vector quantity, vector has magnitude and direction. Okay na? So constant means magnitude constant and direction also should be constant, then only we can say acceleration of the body is constant. Otherwise it is non-uniform acceleration. Understood? If any one is changing in this or both are changing in this, that is considered as a non-uniform acceleration. Clear na? Right, now let us see an object is moving with the uniform acceleration A. Let us take an object is moving with uniform acceleration. So I am observing the body from point A to point B. Before that also it has motion, after this also it has motion, but I am observing from point A to point B. Clear? So when it is in uniform motion, I want to calculate different parameters. What are they? What is the displacement of the body? What is the displacement of the body? And what is its initial velocity? U. Okay, what is its final velocity? Okay na? Or how much time it takes to move from A to B? Understood? These are the parameters I want to calculate. Then how to calculate these parameters when a body performs uniform acceleration? If the body performs uniform motion, we can use this formula directly. V is equal to S by T. When we should use this formula? If the body has uniform motion. Okay na? So when the body has uniform motion, then you can use this formula. Speed is equal to distance by time. Then you can calculate either speed or distance or time, whatever it may be. But in this case, if the body has uniform acceleration, displacement how to calculate? Initial velocity how to calculate? Velocity, final velocity and time. For this we have equations. We have some equations. Those are called equations of motion. What do you call them as, Nana? Equations of motion. Equations of motion. When a body has a uniform acceleration, so to calculate different parameters, we use these equations of motion. So what are they? First one is V is equal to U plus A into T. V is equal to U plus A into T. This is called the first equation of motion. Okay. Similarly, second equation is S is equal to U into T plus half A into T square. This is called second equation of motion. Okay. Next, similarly, third one is V square minus U square is equal to 2 into A into S. This is called third equation of motion. And there is another one, fourth equation, that is Sn is equal to U plus A into N minus half. Okay, so these are the four equations of motion. Apart from this, the basic equation for second and third are that is S is equal to V plus U by 2 into T. Is the base equation for second and third equations. These are the formula. Simply you can call as formula to calculate different parameters when the body has uniform acceleration. Remember that. Uniform acceleration. So if the body has acceleration 0, then we use simply V is equal to S by T. This is the formula to calculate when the body velocity is constant or acceleration is 0. When the body has zero acceleration, then you can use this formula to calculate displacement, velocity, time, whatever it may be. But if the body has uniform acceleration, to calculate different parameters we will be using this. Understood, Nana? Now in this, what is V? I'll be writing all the things here. What is V? Final velocity. What is V, Nana? Final velocity. What is U? Similarly, initial velocity. Okay. What is S? Displacement. Remember this one. It is not distance, it is displacement. Clear? Next, what is A? Already we learned. What is that? Uniform acceleration. It is uniform acceleration. Next, what is T? It's a time of motion. Any other parameters are there? Right. Understood? Now the thing is, when we should use the first equation, second equation, and so. Right? So this first equation is used to calculate velocity of the body. Velocity of the body after t time. Okay? For example, an object is moving. We know initial velocity. For example, an object is moving with initial velocity v. Its uniform acceleration is e. After time t, what is the final velocity? They asked. After time t, what is the velocity? Then I use v is equal to u plus a into t. Understood? You can use for both the motions, either it is accelerated motion or retardation. Are you understanding or not? So when we use this formula, Nana, when you want to calculate velocity of the body after t time, after t seconds. Clear? Now coming to second one. When do we use this formula? Here see displacement. We are calculating displacement. That means this formula is used to calculate displacement of the body after t seconds. To calculate displacement of the body. Displacement of the body after t seconds. Okay, na? An object is moving. We know its initial velocity. Okay, then uniform acceleration is e. After t time, what is the displacement traveled by it? So that you can calculate by using this formula. S is equal to ut plus half at square. Clear? This is used to calculate velocity after t seconds. This is used to calculate displacement after t seconds. Understood, Nana? Now when we will use Sn equal to u plus a into n minus half. What is meant by Sn? Now listen carefully this. Here S is displacement in t seconds. Okay, but sometimes in the problem, okay, so the body has traveled for t seconds, but what is the displacement traveled by it in the last second or last but 1 second? In 1 second, how much distance it has traveled? Understood? So now we are calculating what are the viruses. Already you know this. Okay. How many are affected to corona in India till today? Okay, that is some 1,000 for example. There are 1,000 cases. How many are affected in the last day, means yesterday? It may be 50 or 60. How many are affected day before yesterday? It may be 70. Understood? So this value is changing. Okay, we are calculating for total days and we are calculating for a particular day. Similarly, displacement for total time t. Okay, and displacement for a particular second. Got it? If this is the displacement for 5 seconds, sir, this is the displacement of the body for 5 seconds. If I want to calculate displacement in the third second, displacement in the only third second, how much? Or displacement in the fourth second is how much? Or displacement in the only fifth second, last second is how much? Then I could use this formula. Here Sn is nothing but in the nth second how much displacement it has traveled. Is n may be 1, 2, 3, so on. First second, second second, third second. Okay, 2 seconds is different from second. Okay, what is the difference? In 2 seconds the body has traveled this much distance. Okay, no, sir. 1 second, 2 seconds. In the second means this is the distance traveled by the body in the second, in a particular second. Okay, that is the formula we use to calculate distance traveled by the body in a particular second, that is nth second. Okay, Sn is equal to u. What is this u? Initial velocity. Where, sir? Where should we take? Before starting the second or initial position? This u is initial velocity, starting point at where you are starting your observation. That velocity is the initial velocity. If I want to calculate 4th second, initial velocity should I take here? No. Okay, initial velocity is the body starting where you are observing, that initial velocity. Clear? Right. A is uniform acceleration. N is, and which time you are calculating. 4th means 4, 5 means 5. Okay, minus half. Okay, in this way we will be using this formula. This is used to calculate displacement in t seconds. This is used to calculate displacement in the tth second. Tth, in place of tth I kept n, nth second. Displacement in n seconds, displacement in nth second. I think you got idea. Displacement in n seconds total. This is displacement in the n second, a particular time. Okay, na? So that is. Next, when do we use this one? S is equal to v plus u by 2 into t. See, you observe carefully, in this there is no acceleration term. In all, there is acceleration term. Yes or no? But in this equation, there is no acceleration term, even though the velocity is changing. Right? So, whenever in the given problem, initial velocity is given, final velocity is given, and time is given, and asked to calculate displacement, then you can use this. Okay, generally people, what do they do? First they will be calculating acceleration by v minus u by t. Next they will be using s is equal to ut plus half at square to calculate displacement. Okay, no need to use these two formula, just use this formula to calculate displacement, v plus u by 2 into t. Then you will be getting displacement without acceleration. You don't need to calculate acceleration separately. Instead of using two formula, okay, you can use the single formula to calculate displacement. When acceleration is not given and different velocities are given, initial velocity and final velocities are given. Clear, sir? Everyone? Right. In this way, we can use these equations of motion to calculate different parameters for a body which is moving with uniform acceleration. If the acceleration is 0, this is the simple formula we can use. Clear? Very good. Now you understood when we have to use this one and all. Clear? Now let us see one numerical based on this. Okay. See, first I'll be taking a body is moving with a speed of 5 meters per second. Okay, it uniform acceleration of 2 meters per second square. What is its final velocity after 5 seconds? What is its final velocity, or what is its velocity after 5 seconds? Understood? So I want to calculate v. What is given? U is given. This is very important. You write what is given in the problem first. If you write what is given in the problem, then you can understand which formula we should use. Okay, first write known quantities. U is given, A is given as 2 meters per second square, and T is given as 5 seconds, and V we need to calculate. Got it? So what is the formula connecting these two? U, A, T, V. Yes, that is V is equal to U plus A, T. Understood? This is the formula. Clear, Nana? So that is the advantage of writing given data. First you write by reading the problem carefully, write given data. Okay, if you write given data, half of the problem is solved. So understanding the problem is very important than solving it. So, and after writing given data, you check all the given data is in same system of units or not. This is meter per second, MKS, meter per second square, MKS, second, MKS. So all the given data is in same system of units. Same system of units. If it is not in the same system, then you convert. You know how to convert it. Okay, then you substitute. So u as 5 plus a is 2 into t is 5, that is 5 plus 10, that is 15 meters per second is the velocity of the body after 5 seconds. Understood? Velocity of the body after 5 seconds. Similarly, for the same problem you can calculate what is the displacement. What is the displacement? What is given? U is given 5 meters per second, a is given as 2 meters per second square, t is given 5 seconds. So that yes, you need to calculate. There is the given data. Okay, what is the formula connecting these all? S u a t, s is equal to ut plus half at square. Got it? So that is u into t, 5 into 5, 25 plus half into a is 2 into t square, 25. Okay, 2 gets cancelled. 25 plus 25, it travels 50 meters in 5 seconds. Understood? So we can calculate velocity after 5 seconds by using this formula. We can calculate displacement of the body after 5 seconds by using this formula. So in this lesson, we are learning motion along a straight line, so that distance and displacements are equal until it returns. Until the body returns, distance and displacements are equal. Already we learned this point. Yes, no. So as long as the body is moving in a straight line and never returns, distance and displacements are equal. In this you can use that as distance or displacement, nothing to worry. Clear, sir? Now I want to calculate displacement of the body in the 5th second. In the 5th second. I have calculated for 5 seconds. Now I want to calculate for 5th second. See our answer, how it is going to differ. So S5. Nth second means yes, n. So 5th second means S5 is equal to, what is the formula actually? U plus a into n minus half. Now S5 is equal to, U means initial velocity. At this point only we should take, not at the 4th second. End of the 4th second is not. Okay. So initial velocity is how much? 5 plus a 2 into n is how much? 5 minus half. Okay. That is equal to 5 plus 2 into, what is the LCM? 2. 10 minus 1, 9 by 2. So 2 gets cancelled. 5 plus 9, how much? 14 meter. You see the difference? In 5 seconds it travels 50 meters. This is 50 meters, let us take. Okay, but in the 5th second it travels how much distance? 14 meters. Understood? Similarly, we can calculate in the 4th second how much distance it has traveled. In the 3rd second how much distance it has traveled. Okay, now whatever you want you can calculate. Understood, everyone? Very good. Now let us see one more thing. An object is moving along a straight line. Its initial velocity you know as 2 meter per second, and you know final velocity as 6 meters per second. Okay, the time it takes to change its velocity from 2 meter per second to 6 meter per second is 4 seconds. Then I want to calculate what is the displacement traveled by the body. Okay, so how do you calculate? Tell me. To calculate displacement, what I require? See here, UAT I require. S is equal to UT plus half at square. But I don't know A. It is not given. Okay, now then I can use what is the formula? V plus U by 2 into T. Otherwise, first you calculate A by using V minus U by T. Then you can substitute that S is equal to UT plus half at square. Instead of that, you can use directly this formula. V plus U by 2 into T. How much, sir? That is S is equal to V 6 plus U 2 by 2 into T. How much? 4. Okay, that is 8 by 2, that is 4 into 4, 16 meters. Let us substitute in this way also. First you calculate A. How much is our A value? 6 minus 2, 4. 4 by 4, 1. 1 meter per second square is the acceleration. Now substitute in this formula so that S is equal to ut plus half at square. Therefore S is equal to U, how much sir? 2. 2 into T, 8 plus half A, 1 into T square, 16. Okay, 8 plus 8, how much? 16 meters. 16 meters, 16 meters. Instead of using these two formula, this one and this one, we could use the single formula. Okay, when you know initial velocity, final velocity and time. Understood? So in this way we can solve lot many problems. First you solve basic problems on these equations of motion. I'll give in the worksheet. Clear? After solving those basic problems, we go for some more difficult problems. Okay, in kinematics you have to solve lot many problems. Many problems you have to solve. Okay, so as many as you solve, that much grip you will get on the concepts and working capabilities. Right, Nana? So this is today's class. Thank you very much. Please subscribe my channel and share it to your friends so that our channel will reach to all members. Thank you very much.